Hi, this paper is called Copying Data Between SAS and JSON Files. I'm Bruce Gilsen at the Federal Reserve Board. Welcome. Thanks for coming to my presentation. And here's my information. And we've got a lot of stuff to cover, so we'll go fast. We'll get through it. Okay, so we'll cover introduction. We're copying files between SAS and JSON into JSON, and then files from JSON into SAS. And then we'll talk about Json L files and the JSON PP data step function. Now, what is JSON? It stands for JavaScript Object Notation. It's an open standard file format and data change format. If you know XML, well, it's kind of like XML, except it's kind of a competitor. It uses some of the same kinds of things, and it's used for some of the same purposes. And there's all kinds of good info about JSON on the internet. Starting in SAS 9.4, you can copy SAS datasets to JSON files with PROC JSON, and starting in 9.4 TS1M4, you can copy JSON files to SAS datasets with the JSON engine. Well, we're going to demonstrate with Linux, but everything I do here applies to both Linux and Windows SAS, and we're going to use basic information, simple examples, and the documentation from SAS has much more stuff. So let's start by showing how to copy a SAS dataset to a JSON file. Here's a very small SAS dataset with just 4 variables and 3 observations. Date is a SAS date variable, which we're showing in a formatted way here. And in order to copy this dataset 1 to a JSON file, all we have to do here is say PROC JSON out equals, and that's going to be the location of a JSON file, export 1. 1 is the name of the SAS dataset we want to copy to JSON, and pretty and no SAS tags are a couple of options we're going to use. Pretty means don't put it all on one line, split it up line by line and make it look good. We'll see what that means in a second. And no SAS tags means don't put metadata at the top and bottom. We'll show what that means in a moment as well. So here's our SAS dataset. And now we can compare and show the result. On the right-hand side is the original SAS dataset, and on the left-hand side is the JSON file that we have created. And you can kind of see that it kind of looks sort of parallel, if you will, to a SAS dataset. So that's a baseline example. Now, let's look at some common JSON options, and I've underlined the defaults to make it readable. We use pretty. No pretty, which is default, means it just shows the entire JSON file on one continuous line instead of breaking it up nicely. Sas tags, which is a default, means you get metadata as shown here, curly brace followed by a couple of lines of information at the top and a curly brace at the bottom. No Sas tags, which I'm going to use in most of the examples, takes away that metadata, suppresses it. The next 3, format character, format date, and format numeric, determine whether or not we use existing formats when we write the files to the JSON file. And lastly, trim blanks, which is a default, means that we remove trailing blanks from character data when we write to JSON. And there's other options as well that are in the documentation. And in that first example I showed you, I used pretty and no SAS tags. So now let's look at some alternate ways to write data that use different options instead. We're going to use the same data set in all of these examples. So now we're going to remove the no SAS tags option so that we're going to put the metadata in the file, everything else still the same. And now you can see the output file, the JSON file we've created, and in bold you can see it's added the 3 lines of metadata at the top and the curly brace to match at the bottom. Next example. Now let's take away the pretty option, and we're going to, by default, write the JSON file as one long record. I've put no SAS tags back in for the rest of these examples. And now you can see that instead of laying it out nicely, it's just creating a JSON file with one long record. Okay, next example. Let's use the no format date option in PROC JSON so that the dates are written just as raw SAS date values instead of using the formatting associated with the variable. And now you can see in the JSON file that the 3 values for date are just raw SAS date values, which might or might not be useful. And lastly, let's try the no trim blanks option. What that's going to do is for character variables, in this case country and city, we're going to pad them to the full length of the character variable and not trim off the blanks. And again in bold you can see that country and city, the values now have trailing blanks at the end. Okay. Now, this is some basic examples of how to do PROC JSON, and I think for a lot of stuff, this will get you what you need to do. If you want to do more complicated stuff like controlling containers and nesting and all kinds of fun stuff, you can look in the SAS documentation for PROC JSON and it will talk about it. And that's all I'm going to say about PROC JSON. Okay, now we're going to go the other direction. We're going to copy JSON files into SAS. Now, while PROC JSON to write to JSON was pretty reasonably simple, as we're going to see, copying JSON files into SAS is a much more complicated thing in some cases, and we'll talk about different things about it and how to try to automate it. Now, one concept that we need to understand is the notion of nested versus non-nested JSON files. By non-nested, we mean that it doesn't have nested levels, and the JSON file we created previously is an example of that. And you can kind of conceptually think of that as kind of corresponding to the rectangular notion of a SAS dataset. And of course, those are going to be relatively easy to read into SAS. We'll see examples, on the other hand, of nested JSON files where the keys are nested, which doesn't really correspond as directly to a SAS dataset, and life may get a little bit more complicated. So here is an example from the previous section of a non-nested file. And you can see that it kind of looks like a SAS dataset, and each object, of which there are 3, kind of corresponds to an observation in a SAS dataset. Here, on the other hand, is a simple example. We're going to look at this and actually work with it shortly, of a nested JSON file. You can see that the income tax and sales tax keys are nested inside the taxes key. In other words, there's no actual value for a variable or column called taxes. It's really just it's giving us nesting so that the actual values are contained in income tax and sales tax. And this is different conceptually than the way we think about a SAS data set. Okay, one of the other things to know is that when we create JSON, we copy JSON files into SAS data sets, they will create variables called ordinal variables that provide relationships between the generated data sets. And with the non-nested files, we can probably not worry about them, but with nested files, we'll want to use them possibly to merge data sets and get a meaningful result. We'll see that by example. Okay, now the other thing is that when I started doing this, I really hoped to automate this process. That was a major objective. And I'm still working on this. I've got cases, as you'll see, that automate very nicely, and ones that really don't, and ones that are in between. And I'm hoping that people who see this presentation or read the paper in the proceedings will have their own ideas about how to automate this process. As we talk through these examples, I think you'll begin to get a feel about what I mean by automating the process, by able to generalize it so that it's not, I don't have to look at the data values. I can write generalized code that will read into SAS. Here's our first example. We've got the same non-nested JSON file that we actually created in the previous section with PROC JSON. And it's just non-nested. It's very straightforward and simple. Okay, now, how do we process that? First, we make a live name statement that points to a library where we're going to write the SAS data sets. That's live name XXX. Then, in case there's anything in it already, just to be safe, we can run proc datasets and clean out the contents there so that we'll have just stuff from this JSON file. Then we're going to do a live name statement for EX31 to point to the JSON file. Then we're going to do proc copy to copy from the JSON file into the SAS library. And then we can use proc datasets to print out the files that are in there. And in fact, in this case, I'm not going to show you the proc datasets output from the log, but it creates datasets called all data and root. Here is all data. We'll look at all data later, but just know that all data, when there's multiple data sets created, all data has all of the data from the JSON file in one long data set, and we'll talk about that later. Here's at the bottom is root, and that is the other data set created. And what you can see is that other than this ordinal root variable, it actually, because it's not nested, it has all the data that we need. So this is actually pretty simple so far. So all we have to do is read the data set and drop any ordinal variables as shown in the code here, and our data set root has a SAS data set that contains the JSON data that we want to read. And this is the kind of the easiest case. But let's not get overconfident. It's going to get trickier. Okay, so here is the first object of a nested JSON file. And you can see that income tax and sales tax are nested inside the taxes keys. This gets a little trickier. Now, here is the entire JSON file just briefly, and you can see it's got three objects that kind of have the same structure with taxes, with income tax and sales tax nested inside taxes. So how do we process this? Well, first we do a live name statement to point to the SAS library we want to write to. We use PROC Datasets again to clean it out. We do a live name ex32 to point to the JSON file. When we do that, we add some options here. First of all, automap is telling us to create, automap you create means make a JSON map. And the map equals is the location of the JSON map. And ordinal count equal all means make all possible ordinal variables to help us combine data sets later. By default, it only defaults to 2, but we need all of them. Okay, then as before, we do proc copy. We copy the JSON file to a SAS data set. We use proc datasets to print them out. And at this point, we get 3 data sets, all data, root, and tax. Now, here's all data. Again, we're going to use this as an example, just for illustration. Here are root and tax. And what you can see is that the ordinal underscore root variable will connect those 2 data sets and allow us to merge them together fairly easily. But I want to generalize this. So I could just do a merge of root and tax, but to make this more generalized, what I'm going to do instead is I really want to merge by all data sets in that library except all data. That's, by the way, part of the reasons I did the proc datasets with delete was to clean out anything that might have been there before so I know exactly what's in there. So I don't have time to talk through the proc SQL code here, but know that what I'm doing is I'm reading a dictionary table to extract from that library all data sets other than all data and copying it to a macro variable called all but all data. Then I'm using that macro variable in a merge statement that's going to merge all the data sets in that library except all data to create one final data set, and that generalizes it. And here are the 2 component data sets, everything except all data. And after I do the merge, you can see at the bottom that I've correctly created this data set. Okay, next example. Now we're going to get a little bit more complicated. Now we have nesting on 3 levels. You can see that tax, then there's income tax, which has income tax underscore estimated and income tax underscore withheld and so on and so forth. So now we've got 3 levels. And by the way, we don't have to have every single value at every level of nesting. As you'll see here, for example, in the second object, for Canada, we don't have income tax underscore estimated, and we don't have car tax underscore H2. And as we'll see in the final SAS data set, those ultimately become, as you might imagine, SAS missing values, and that's perfectly okay. So now we're going to repeat the same half a dozen lines of code to read the JSON file and create a series of SAS data sets in the SAS library. This is the same half dozen lines of code with just the names changed from the previous example, but it's going to create more data sets now because of the nesting. It's actually going to create all the data sets you see at the bottom, all data, root, tax, tax underscore car tax, tax underscore income tax. So here, this may intuitively give you some sense, this slide, of what's really going on here. Here is the first object of test3.json at the top, and let's talk about where the values actually go. The root data set contains values for country, city, and income. These are kind of the values that are not nested at all. Tax contains, the tax data set contains the value of sales tax, which is directly underneath tax. Tax underscore car tax is a data set that has the values for car tax underscore H1 and H2, which are the values directly under there. And tax underscore income tax is the data set that has the values for income tax estimated and withheld, which are the values directly under there. And this, if you stare at this for a while, it may give you some intuitive sense of kind of how those component data sets get divvied up. So here, I'll show you all the data sets except all data, and you can see what they look like. And this is just a more complicated version of the previous example where ordinal underscore root connects all the data sets. So again, I'm going to do the same thing as before. I'm going to read the dictionary table and create a macro variable that has all the data set names except all data in that library, and just merge using all those data sets in a data step and by ordinal root, and I'm going to get one combined data set. And you can see that final data set here. So far, we're doing great. These examples don't look too hard, but as we're going to see in a second, it quickly can become more difficult. Next example, let's read a file with named collisions and retained variables. Now, here's a kind of different looking JSON file. Here's just the first object of the file. There's more below it, but you can see two key differences. First of all, there are two different properties called type. There's one that has to do with full-time or part-time. That's that first one. And then further down, there's another property called type that refers to the type of phone, cell or home. And so type is really two different things in this JSON file. And you could imagine that a variable that does two different things in a SAS data set, why that wouldn't work very well. So clearly, if we tried to just do the kind of merging we're doing, this kind of name collision would cause trouble. The second thing is that you'll notice that the type of employee, that's at the very top there, is really used for 4 records in the ultimate data set. There's 2 blocks of 2 records with name and age, and all 4 of those really will want to have the type of full. And then for name plus age, each of those values, Eric and 21 or John 22, are also used for 2 observations each. So this is much different than what we've been doing before. And here, just for reference, is the full JSON file, which I took from the SAS documentation. Now, we could do the same things we did before to create a bunch of data sets in the SAS library, and I'm doing that right here. And I'm not showing all data, but I'm showing all the other ones. And you can see that I've got these 3 data sets, root, info, and info phone. And you can see that ordinal root doesn't quite sync up in the same way because there are repeat values. And here's the all data set. And by the way, I want you to notice that the P variables, P1, P2, P3 in this case, show the names of the keys, and they show them in a way that reflects the nesting in the file. And you'll notice that type is in P1 and P3, which reflects the problem I noted earlier. Now, in the documentation, what SAS did was they manually edited the JSON map file and made a whole lot of changes. I did something different. What I did was I simply, realizing that type had 2 different purposes, I renamed type property for type of employee to type EMP in the original JSON file, and then I could do a merge in 2 stages that did actually get the data set into one data set. And by the way, to look for these kind of name collisions, as I mentioned on the previous slide, if you see the same variable name in more than one of the P variables in the all data data set, that's how you know you have a collision. In the paper, I've got a macro that looks through all data, the P variables, and looks for repeats in different P variables to see if there's a repeat. So here is the 2 merges that I did in order to take the original component data sets of info, phone, and root and put them together. And in 2 merges, I've managed to create a final data set that has all the data that we want. So this requires a little bit different way of looking at it, but there is still the opportunity to do a fairly automated merge and also to look for name repeats. Okay, next example. Now, here we're going to do test5.json, and we're going to see that we're going to have to do something different. Okay, now this is a little convoluted, but the JSON file scrolls down the left-hand side, and then it continues on the upper right to finish. That's the only way I could fit it. And the ultimate data set that we want to get is going to be the 3 observations that are at the bottom of this slide. I should point out, by the way, that everything in this paper and then some in this presentation is in the paper that's going to be in the proceedings, so don't worry about that. So again, you can see there is some nesting here, and you can see the ultimate result. Now, if I do the same code as before, the problem is I get a bunch of data sets, the component data sets, everything except all data, that kind of looks like this. And you'll notice that all the ordinal variables are 1. That's just not going to help us very much. It's going to be very hard to piece this together. So for this kind of data set, I took a different approach. I decided instead to read the all data data set. Now here's the first 13 records of the all data data set to give you enough of it to understand what I'm trying to do here. Now, to read the all data data set, the key is that the records where v equals 1 are the actual values that we want to put into the resulting data set. And so, for example, in observation 4, v is equal to 1, and the value we want to capture is number of New York Knicks titles. The variable, the way we figure out what variable to assign that to is we start from the highest p variable and we work our way left and we pick the first one that is not blank. So for observation 4, p5 is blank, but p4 is question. So the assignment statement we want here is question equals number of New York Knicks titles. That's the variable that we're assigning a value. That's how we would do it. And likewise in observation 6, where v is equal to 1, we're going to say option 1 equals the character string ONE. So we can basically work our way through the all data data set, and we can pick off all the values and just assign them to variables this way. I've got code that does this in detail in the paper. I'll just note a couple of things. One is that the variables in question can be character and numeric, and owing to the nature of and I've got examples in the paper, the same variable can be in the component data sets can be character in some and numeric in others. Whenever that's the case, what I do is I look through all the component data sets, everything except all data, and anything that's character in any data set, that variable is treated as a character variable, and if the lengths are different, I use the longest possible length to avoid truncation. And the point is, this is code that I can write that would automate this process, that would go through the all data data set and create a SAS data set. And let me go back actually, sorry. And so again, by reading that all data data set, I am able to create the data set that's shown at the bottom of this slide. Okay. One last technical point here. The very first variable that I ever find the first time v is equal to 1 is question. That indicates to me that every time I encounter question again, it's the beginning of a new observation. And that's all I'm going to say about this. The paper actually has all the code that does this. Okay, last example. This one is taken from the documentation for the JSON engine in the SAS documentation. Now, what happens in this case is that we're going to take the code that SAS provides takes advantage of the information about the file. And let me just show you what I mean by that. Here is the all data data set, the first 19 records of it that is used in this last example. And what SAS generated from this example was the following data set. And what you can see is that it captures all the values, but that there is a column called item that has the type of food. And if we go back to the all data data set, you can see that the values of item are taken from the P3 variable, P3 column of all data. But there's nothing in here that says item. There's nothing in here that tells us to call it that. There's nothing in here that says that we want to use that as part of the output data set. But this is the kind of case where the person writing this has an understanding of what they want the result to look like. And at this point, my belief is that for a case like this, the kinds of automated code that I've shown you in the previous examples probably is not what you'll want to do. You'll want to write it manually and just do what you wish to do. And for now, that's the answer. Okay, now I've given you a whole bunch of examples of reading JSON files into SAS, and I just want to again emphasize the fact that this is an area of ongoing research. I'm trying to learn how to automate more of these, and I hope you will provide me with assistance and contact me with ideas. But let's go on to our next couple of final topics. What's a JSON L file? A JSON L file, that's a relatively new format. It stands for JSON L or JSON lines. And what it means, as shown at the example at the bottom, is that each text line is a valid JSON object, but they're not connected to each other. So even though each individual line is a valid JSON file, the actual overall file isn't a valid JSON file. What we can do here is we can use a data step to convert our JSON L file to a JSON file. And here is code to do that. I've got the JSON L file at the top, and here's just a relatively straightforward data step where we read each record, write it out. We put some extra characters in at the top, bottom, before lines to turn the JSON L file into a valid JSON file. And this will be in the paper. And again, here at the top is our JSON L file, and at the bottom is our JSON file. And you can see we've added the open and closed brackets, we've added the commas between records, and we've turned our JSON L file into a JSON file. So while we can't read JSON L directly, we can convert it to JSON. Last topic, the JSON PP data step function. We talked at the beginning about how the pretty JSON file is human readable, spread out one with indentation and lots of lines, that otherwise it's all just one continuous line. Should you have a one continuous line JSON file like the one shown at the middle of this slide, and you'd like to convert it to a pretty JSON file, you can use the JSON PP function as shown at the bottom of the slide. You just pass in the first argument is the existing unpretty JSON file, and the second argument is the now created pretty JSON file. And that's all there is to it. And here's the pretty JSON file, one we've used before, that we created from the unpretty JSON file. Okay, now here's my conclusion. And again, I want to say, I feel like I've been in uncharted territory here. I haven't seen much about JSON anywhere, and I'm still working on this. I'm still learning, and I'm hoping to learn from you. But I can tell you that starting in SAS 9.4, we can use PROC JSON to copy SAS datasets to JSON files. Not too hard to do, as you saw in most cases. Starting in 9.4 TS1M4, we can copy JSON files to SAS datasets with a JSON engine. It can be simple. We saw that in the first three examples. It can get medium hard, or it can get very hard or almost impossible to do in an automated fashion where we would have to code it manually. And I'm hoping to expand this over time and learn more. So I would appreciate your assistance. We also talked about JSON L files, and we talked about the JSON PP data step function. And here is my standard last and most profound slide. And thank you very much. Here's my contact info, and I really appreciate everybody checking out this presentation and hope to hear from you. Thank you very much.